Hello students. Now we begin Unit 2, Deep Neural Networks, and I want you to feel excited and confident because these are the most important and most predicted questions for your semester exams. I am explaining everything calmly, clearly, and with full energy, just like a caring lady teacher in a classroom, so that even a 10-year-old student understands every concept deeply. We start with the question. Explain the biological neuron and its analogy with artificial neural networks. A biological neuron is a basic unit of the human brain. It has dendrites that receive signals, a cell body that processes signals, and an axon that sends signals to other neurons. In artificial neural networks, this idea is copied in a simple mathematical form. Inputs act like dendrites, weights decide the strength of each input, the summation acts like the cell body, and the output acts like the axon. Just like biological neurons fire signals based on input strength, artificial neurons produce output based on weighted inputs and an activation function. Now, let us move on to our next important topic, perceptron. From this topic, we can expect questions such as, what is a perceptron? What are the steps involved for training a perceptron in deep learning? A perceptron is the simplest form of an artificial neural network. It takes multiple inputs, multiplies them with weights, adds a bias, and passes the result through an activation function to produce an output. Training a perceptron involves initializing weights, passing input data, calculating output, comparing it with expected output, finding the error, and updating weights to reduce this error. This process repeats until the perceptron learns correctly. Now, let us move on to our next important topic, multilayer feed-forward network. From this topic, we can expect questions such as, what is perceptron? Write short note on multilayer feed-forward network with figure. A multilayer feed-forward network contains an input layer, one or more hidden layers, and an output layer. Information flows only in one direction, from input to output. If I explain the figure in words, imagine inputs entering from the left, passing through several layers of neurons where each layer extracts more complex features, and finally producing output on the right. Hidden layers allow the network to solve complex problems that a single perceptron cannot solve. Now, let us move on to our next important topic, training neural networks. From this topic, we can expect questions such as, explain how a neural network can be trained with backpropagation and forward propagation methods. In forward propagation, input data moves layer by layer through the network to produce an output. This output is compared with the expected result to calculate error. In backpropagation, this error moves backward through the network to update weights using gradients. Together, forward and back propagation help the network learn from data. Now, let us move on to our next important topic, comparison of back propagation and forward propagation. From this topic, we can expect questions such as, compare back propagation and forward propagation. Forward propagation is used to generate output from input data, while back propagation is used to adjust weights based on error. Forward propagation moves information forward, while back propagation moves error backward. Both are essential for training deep neural networks. Now, let us move on to our next important topic, activation functions. From this topic, we can expect questions such as, enlist activation functions used in deep neural network. Explain any two of them in detail. Activation functions decide whether a neuron should activate or not. Common activation functions include linear, sigmoid, tanha, hard tanha, rectified linear unit, and softmax. For example, sigmoid squashes values between 0 and 1, making it useful for probability-based outputs. Rectified linear unit outputs 0 for negative values and passes positive values directly, making learning faster and efficient. Now, let us move on to our next important topic, detailed activation functions. From this topic, we can expect questions such as, explain linear sigmoid tanha hard tan softmax and rectified linear unit activation functions with suitable diagrams. If I explain diagrams in words, linear activation shows a straight line where output increases directly with input. Sigmoid looks like an S-shaped curve that slowly rises and flattens at the top and bottom. Tanha is similar but centered around 0. Hard Tanha is a clipped version of Tanha. Rectified linear unit looks like a flat line at 0 for negative values and a straight rising line for positive values. Softmax converts outputs into probabilities that sum to 1. Now, let us move on to our next important topic, loss functions. From this topic, we can expect questions such as, define loss functions used in deep neural network enlist and explain any two of them in detail. Loss functions measure how far the predicted output is from the actual output. Mean squared error is commonly used for regression problems where it measures average squared difference. Cross-entropy loss is used for classification and measures how well predicted probabilities match actual classes. Lower loss means better model performance. Now, let us move on to our next important topic, types of loss functions. From this topic, we can expect questions such as, enlist and explain different loss functions used in neural network. Different loss functions are designed for different tasks. Regression tasks use squared error-based losses. Classification tasks use cross-entropy-based losses. Reconstruction tasks use losses that measure similarity between original and reconstructed data. Choosing the right loss function is critical for learning. Now, let us move on to our next important topic, hyperparameters. From this topic, we can expect questions such as, write short note on hyperparameters used in neural network. Hyperparameters are settings that control how a neural network learns. They are chosen before training and strongly affect performance. Examples include learning rate, regularization strength, and momentum. Proper tuning of hyperparameters improves accuracy and stability. Now, let us move on to our next important topic, important hyperparameters. From this topic, we can expect questions such as, explain learning rate, regularization momentum, and sparsity as hyperparameters in deep neural networks. Learning rate controls how fast weights update. Regularization prevents overfitting by limiting model complexity. Momentum helps speed up learning by smoothing weight updates. Sparsity encourages fewer active neurons, improving efficiency and generalization. Now, let us move on to our next important topic, deep feed-forward network with exclusive or example. From this topic, we can expect questions such as, explain deep feed-forward networks with exclusive or example and role of hidden units. Exclusive or is a problem that cannot be solved by a single perceptron. Deep feed-forward networks solve it using hidden units that learn intermediate patterns. Hidden units transform input space so that output becomes separable and learnable. Now, let us move on to our next important topic, cost functions and error backpropagation. From this topic, we can expect questions such as, explain cost functions and error backpropagation in deep neural networks. Cost functions measure total error across all outputs. Error backpropagation distributes this error backward through the network to update weights efficiently. This process allows deep networks to learn complex relationships. Now, let us move on to our next important topic, gradient-based learning. From this topic, we can expect questions such as, explain gradient-based learning and implementation of gradient descent. Gradient-based learning uses gradients to find the direction of minimum error. Gradient descent updates weight step by step in the direction that reduces loss. This iterative process continues until the network reaches optimal performance. Now, let us move on to our next important topic, vanishing and exploding gradient problem. From this topic, we can expect questions such as, explain vanishing and exploding gradient problem in deep neural networks. Vanishing gradient occurs when gradients become very small and stop learning. Exploding gradient occurs when gradients become very large and cause unstable updates. Proper initialization, activation functions, and normalization techniques help solve these problems. Now, let us move on to our next important topic, sentiment analysis. From this topic, we can expect questions such as, explain sentiment analysis in detail. Sentiment analysis uses deep learning to understand emotions and opinions in text. It classifies text as positive, negative, or neutral by learning patterns in language. It is widely used in reviews, social media, and customer feedback analysis. Now, let us move on to our next important topic, PyTorch and Collab. From this topic, we can expect questions such as, write short note on PyTorch and Collab. PyTorch is a deep learning framework that provides flexibility and dynamic computation graphs. Collab is a cloud-based environment that allows running deep learning code without local setup. Together, they make experimentation fast and easy. Now, let us move on to our next important topic, Jupyter Notebook. From this topic, we can expect questions such as, explain the role of Jupyter Notebook in deep learning experiments. Jupyter Notebook provides an interactive environment where code, output, and explanation exist together. It helps in experimenting, visualizing results, and documenting deep learning models clearly. With this, students, we complete Unit 2. And if you revise these concepts with focus and confidence, you are fully prepared to score excellent marks and truly understand deep neural networks.